Hi. Earlier on I gave an example of calculating the curvature of the Earth using Pythagoras for a ship that was 20 kilometres offshore. There is a better way of doing that using trigonometry, but it gets a fairly similar answer. But if you're interested, I'll just go through the mathematics for doing it using Trig. So we'll draw a circle for the Earth. So we'll colour the Earth be a green Earth. So there's the Earth, and we need to draw a couple of lines on that. So let's draw a line down through the centre here. And then we'll draw a line off at an angle from the centre. And we'll draw a line coming back to the centre line. Okay. So if you remember your trigonometry, if this is the angle here, theta, we call this line here the hypotenuse, and this angle here is the opposite, and this angle here is the adjacent. And the cosine rule, so cos, is equal to the adjacent over the hypotenuse. And that's a ratio. So the cos of that angle will be an angle that's less than 1. And the tighter the angle is, the closer to 1 that will be. Okay. Now, what we needed to work out was the curvature of the Earth. And in this diagram, the curvature of the Earth is h, which is the distance from here to here. And to work out that, it's the radius of the circle, take away this section here, which is from here to here. So h will be equal to the radius of the circle minus the radius of the circle times this ratio, which is the adjacent over the hypotenuse, which is also called the cos of the angle. And the way you normally write that is you've got a common factor of r, so you take that out the front, put in a bracket, r1 times r is r, minus, divide cos theta. So here we now have the formula for the height in trigonometry. Okay, so that's the mathematics behind it. Now let's just do a check to see if that works. So I've got a calculator over here, a scientific calculator. So let's just memory clear and clear everything in the calculator, so there's nothing there. And let's do our sum from the last exercises. Let's say what we have to do is first of all convert the distance here. So if we look at this part of the circle, that was what we can measure, which is part of the circumference of the circle. So we've got to convert that into degrees. So we're using the formula, the circumference of the circle is equal to 2 pi r. So finding out what the circumference of the Earth is using the radius. So we know the radius of the circle of the Earth is equal to 6371 kilometres. So 2 times pi times 6371 equals 40,030 kilometres. So to calculate the angle from that distance there, we need to know that there are 360 degrees in a circle, and if we want to find out what 1 kilometre is, we need to divide that by 40,030 kilometres. So let's do that. So we've got 360 divided by 40030 equals, oh, something wrong there. 360 divided by, I think I multiplied, 40030 equals. Okay, so the answer is equal to 0.009 degrees. So for every 1 kilometre, we have 9 degrees. So let's give some more working space. Let's now look at the example for 20 kilometres. So we want to use the formula H. H is equal to R, which is 6371 brackets times 1 minus cos of the angle. Now the angle is 20 times 0.009, those brackets. So we don't need a calculator for all of that. We can now make that 6371 times 1 minus cos, and 20 times 0.009 is the cos of 0.18. Okay, so I'll now put that in the calculator. So in the calculator we now have, this is the way we do it on the calculator, 0.18 cos. So we've now got the cos. We now add that to memory and clear. Now we've got to do 1 minus that, 1 minus memory recall equals, we've now got a very small number. And now we've got to multiply it by the radius of the Earth. So we've now got that number times 6371 equals. The answer is 0.0314. So I'll just leave it at that. And the units are kilometres. And we can convert that to metres, which is the answer that we had before. Okay, so there we are. That's how to work out the curvature of the Earth using trigonometry. Okay, hope that was helpful and a bit of fun. Again, this is part of the critical thinking course. What we're using here is we're using facts. So on this collection here, we have some facts that we know. We have a formula. We have another formula over here. They're facts. And then we're using logic, the logic of mathematics, to come to an answer. So this is part of critical thinking, and then we can apply that to our reasoning. And in the previous example was proving that the Earth was not flat. Okay, thank you.